In this question, we're going to look at 3 different cases that can occur. The first case is when we have n is 1 bigger than a multiple of 3. And if we look at the sequence here, we've got 1, 2, 3, 4, and we carry on up to 2n, and the term before that is 2n minus 1. Now, we're going to consider the first term and the last term, like this, which is there, and the next 2 in, which is like that. And if we look at the pairs formed by this idea, then we can see that each of them will add up to 2n plus 1. Now, what's the point of that? Well, it's actually really useful, because if we know that n is 1 bigger than a multiple of 3, then 2n is going to be 2 bigger, plus we've got an extra 1, so it's going to be 3 bigger than a multiple of 3, which makes it in itself a multiple of 3 as well. So we've now covered that particular case. Okay, now we're going to look at the case when n is a multiple of 3, and we're going to follow the same idea as in the first part, but we're going to have a look a little more closely at it, because there are some little technical bits at the end that are quite tricky to deal with. So the first thing we're going to do is let n equal to 3k. Now that's clearly a multiple of 3. And so that helps us with this. Now, if we look at the sequence here, we've got 1, 2, 3, and then this goes on. And what we're going to do is to look at the last 4 or 5 terms here, and they end up being okay. So we've got then the next 4 terms here. Okay, we've got the sequence there, and what we're going to do now is to ignore the last 4 terms, and in fact we're going to erase them. And now we're going to look at this series here. And if we can now notice that 6k minus 4 is an even number, and that then fits into the same system as we had in the first case, where we can now start pairing them up here. So we've got that pair there and this pair here. And if we look at those pairs, we've got 6k minus 4 plus 1, which gives us 6k minus 3. And if we look at the second pairing here, which is 6k minus 5 plus 2, we get the same result as well. In fact, if we look at every pair that's there, the larger number goes down by 1 and the smaller number goes up by 1, and therefore the sum will always remain the same. If we now look at these last 4 terms that we discounted at the beginning because it made the pairings easy to see, if we now look at these and we pair them up here, like this, each pair, which we've got here, 6k minus 3, plus 6k, which gives us 12k minus 3. And if we look at the other pair as well, we notice we get the same result, and those are both multiples of 3 as well. We've now looked at cases 1 and 2, which are multiples of 3 and 1 more than a multiple of 3, and now we complete the set by looking at 1 less than a multiple of 3. And if we write out the sequence here, we're then going to look at the pairings as we did in the previous sections, which are like that, and like that, and so on. And in each case, we end up with 2n plus 1. And just to check that we're on the right track, we've got 2 plus 2n minus 1, which gives us the same result as before. Each one is 2n plus 1. Now looking at that, all the pairings will give us that, and we notice that we've got n lots of that. So the sum total of all those is n lots of 2n plus 1. Now, what is that going to tell us here? If we look, n is 1 less than a multiple of 3, so that term there is 1 less than a multiple of 3, which is clearly not a multiple of 3. And we look at this one here, so if n is 1 less than a multiple of 3, this whole term here, 2n plus 1, is 1 less than a multiple of 3. And both the two components of this are not multiples of 3, and so the whole sum of this whole sequence is not a multiple of 3. If each pair sums to a multiple of 3, then the total of the numbers 1 to 2n must be a multiple of 3 as well. And in this case, it isn't a multiple of 3. So we cannot produce a set of pairings where the sum of each pair is a multiple of 3.